Hello and welcome to Tiny Code Christmas Day 4. 12 days of size coding and demo scene effects for fantasy consoles. If you've just joined us, don't forget to check out Day 1 and the Tiny Code Christmas website for the full picture. If you're enjoying Tiny Code Christmas, please share your work with us on socials using the hashtag LoveByteTCC. First, we're going to talk about sine and cosine, and this is relevant to both platforms, so stay tuned and then we'll split off for platform-specific code samples. We're going to take a look at the sine and cosine trigonometric functions. This is a circle with the center point at 0, 0 and a radius of 1 unit. So this is called a unit circle. So let's take a look at some of the points around this circle. So we have 1, 0, where there is 1 unit on the x-axis and 0 on the y. Up here we're at point 0 on the x-axis and 1 on y. And down here we're at minus 1 on x, 0 on y. And down here we're at 0 on x and minus 1 on y. This unit circle is essential for understanding sine and cosine values. These trigonometric functions are derived from a triangle formed at a given point on the circle. So if we take a look here, I'm going to increase this angle a bit, and the sine represents the ratio of the opposite, so the side of the triangle opposite of this angle, over the hypotenuse, and that will give us the position, the y position of that point on the circle. The cosine represents the adjacent side, which is this, over the hypotenuse. So I'm just going to animate this point moving around the circle, and we can see that there's two measurements of the angle here. We have an angle in radians and we have an angle in degrees, and they are different values for the same angle. So I'm going to get this as close as I can to 1 radian, and we have, I think most people have an understanding of the 0 to 360 degree angles, but radians are something that you may not have used in a while. So a radian is the distance of when this arc is 1 radius in length, the corresponding angle is 1 radian. And 1 radian is approximately 57.3 degrees. This angle measurement relates to the fact that a circle's diameter fits into its circumference approximately 3.14 times, which is the basis of the constant pi. And in terms of radians, there are 2 pi radians in a full circle. So the sine and cosine functions can be thought of as giving us the y coordinate with the sine and the x coordinate with the cosine. And this is for a point somewhere along the circumference of the circle when it's a unit circle. So for example, I'm stopping here now at approximately 0.8 radians or 45.84 degrees, and from this we can see that the x and y coordinates of the point over here, the x coordinate is 0.7, so that's here, and that is the cosine of that angle, sine of 45.84, or the sine of 0.8 radians, and 0.72 over here is the sine of 45.84 degrees or 0.8 radians. And you can see as we move the angle, as we change the angle and move the point around the circle, you'll see that these values change in line with that. So take a look at the sine in orange and the cosine in blue as the values vary with the angle, and we see smooth motion that slows down at the extremes before reversing. And these functions will always return a value between -1 and 1. The output of these functions will often be combined with the time or the location on screen in order to give us a value that we can then use as part of an effect or a rotation. So we're going to take a look today at creating a plasma effect which makes use of sine values. So let's take a look at the TIC80 first, and then we'll take a look at the Pico 8. What we're going to do today is we are going to change the pixel effect to be what's known as a plasma effect, and we are going to use the sine function that we just talked about to help us decide on the color for each individual pixel on the screen. So the first thing that I'm going to do is I'm going to create a variable called C and pop that in there. So I'm setting the X and Y coordinate from the for loop to be whatever the value of C is as the color. And obviously this is creating an extra variable, so this isn't going to be the most size coded friendly solution here. So if you come up with something nice, you can pop it directly in here to save a few characters. So first thing that I'm going to do is I'm going to use the sine function on the X value, and I'm going to add it to the sine function for the Y value. So we are using the sine function not to get the result of an angle, but just to give us a value based on the position of the current pixel. So the sine of X, the sine of Y. Let's run this code and see what happens. So this gives us a pattern, and we can see that the colors here are black, which is 0, purple, which is 1, and grey, which is 15. So what's happening here is mat.sine gives us a value between -1 and +1, and that is what's happening. We're kind of limiting our colors because the values are only potentially going to be from -2 to +2. And what I want to do here is multiply this by 8. So if it's -2 to +2, if we multiply it by 8, that gets us up to the 16 for the 16 colors. And if I run it, we can see that we do in fact have a lot of colors here on this effect, and you can kind of see some circles appearing due to the use of the sine function. So this is a bit compact, so I'm going to spread it out so that X is going to change at a slower rate and Y is going to change at a slower rate, and that should give us a bigger plasma effect. So that is the effect that we're going for here, and you can see that we've used those sine values to create this effect. So I want to make this code a bit shorter, so what I'm going to do is I'm going to alias the mat.sine function to a shorter variable called sine, and then anywhere in my program I can type sine instead of typing mat.sine, and that will save me a few characters. So your challenge for today is to animate this plasma effect, add some more signs, come up with something that is interesting. You can vary the signs based on the time, you can vary it based on the location, and you have the groundwork for a very interesting effect. Today's challenge is to complete this in 128 characters. Don't forget to check the website for expert challenges. Best of luck. So now we're going to take a look at building a plasma effect. This is our per pixel effect code from yesterday, where I just have the X plus Y. So the first thing I'm going to do is create a variable called C, and that is going to hold my color. And I'm going to change this to C, so it'll set the pixel X and Y to the color that we calculate here with C. So what we're going to do is we're going to use sine values based on the position on the screen to give us to define our color. So we're not using this to actually work with a circle or to work with angles or anything like that. We're literally just getting the sine of some values based on their position on the screen, and we're going to use that to dictate the color. So I'm going to get the sine of X and I'm going to add it to the sine of Y. Now the angle in terms of pico 8, it doesn't take degrees or it doesn't take radians, it takes turns. So it actually takes a value between 0 and 1. 0 to 127 is going to be 0, 1, 2, 3, 4, and if the turns are 0 to 1, this is just going to be the same angle the whole time. And if I run this, we'll see that it does in fact give us absolutely nothing. So I need to make this so that it gives us some kind of a decimal number. Okay, we're getting somewhere. So the whole point here is that these are going to be whole numbers between 0 and 127. So we need this to give us some kind of a decimal value that isn't a whole number, and we can just do that by dividing by 80 or some other number you can mess around and see. So when I run it, I do get a kind of a plasma effect, and the sign values here for Pico 8 give us -1 to 1, -1 to 1, and if we add them together, we're potentially between plus and minus 2. So we could multiply that by 4 maybe, and you can see now that we do have all of the colors represented here. So obviously with Pico 8, the palette doesn't lend itself to a gradient, so when you're approaching today's challenge, you have the option to use the palette code from yesterday, but to leave that out of your calculations for your size. Your challenge is to create an animated plasma that is based on, and then you can add more sign values to it to create different patterns. You can vary the X's and Y's, you can add the time, you can change the divisor to get some kind of an interesting effect. And your challenge is to do that within 128 characters. Don't forget to check the website for expert challenges. Best of luck.